Welcome everyone to this talk on carbon emissions in builds and retrofits by Mark Brinkley. I hope that's what you expected. So this is one of a series of online talks and home tours run by Open Eco Homes, which is a project of Cambridge Carbon Footprint. I'm Tom Bragg, Open Eco Homes manager and your chair for this evening. So I'm starting with a few announcements, won't take long. So you've noticed probably we're recording this talk for the benefit of people who can't be here. It will go on YouTube in a bit tomorrow. When it goes online, your name labels, you can probably see a name label for everyone, but those won't show when it goes online. And if you're willing, we'd love you to turn on your cameras so we can see our audience. But that's your choice, of course. And if you don't want to be seen in this video, then maybe you need to keep your camera off. Hello, yes, I'm seeing a few more people now. And so, yeah, so tomorrow we'll email everyone who's booked. So the people here and those who booked but couldn't make it, with links to this video recording and Mark's slides and the other material that will let you follow up on this. And so as we go along in Mark's talk, please write your questions for him in Zoom chat. That's at the bottom, maybe the top of your Zoom screen. There's a little kind of speech bubble, or you may find it through more. So anyway, you can just write messages to us, and so put your questions in there, please. And then after Mark's presentation, Samin Ishtiaq, who is here as well, helping us, will call on people with chat questions to unmute and ask the question. But otherwise, please stay muted, and then we won't get weird noises. So we're going to finish at 8:30, but if there's still more questions and discussion to be had, we'll then have extra time for those who want to stay on. So you probably know that Mark Brinkley is the author of the House Builder's Bible, deservedly the most popular book of its kind, now in its 14th edition. I mean it, it's really good. And he's also given fascinating Open Eco Homes tours of his self-built home in person and online. So I'm really looking forward to hearing what Mark's take is on carbon emissions in building and retrofits. So over to you, Mark.
Well, good evening, everyone. Thanks for that introduction, Tom. That many of you already know who I am, but for those who don't, I've been a writer and journalist covering self-build and energy efficiency matters for the past 25 years. And as Tom says, I've recently built a low energy house in Sedgwick Street in Cambridge. And tonight I want to talk to you about one of the lesser aspects of low energy home building, which we've entitled here, Carbon Emissions and Builds and Retrofits. And I'll get the screen up and see if I can share it with you. Here we are, here's our opening slide. Embodied carbon is not a topic that gets as much attention as reducing carbon emissions for energy in use. And what I mean by energy in use is the energy that's used to heat our homes, our domestic hot water, and to power our lights and appliances. The stuff that results in gas bills, electricity bills, the sort of thing you can measure by the size of these bills. And we've got two ways basically of addressing energy in use and carbon emissions. Firstly, we can reduce our demand by putting in energy efficiency measures. And secondly, we can switch to low carbon forms of energy supply, such as heat pumps and solar panels. Such measures will in large part form the subject matter of most of the presentations in this year's Open Eco Homes events, but not tonight. Here, I want to explore embodied carbon. And this refers to the carbon dioxide emitted before our building materials even get to site. In the past, we've largely ignored it. It's seen as a bit of a geeky subject, a sort of footnote in our battle to reduce overall carbon dioxide emissions. Indeed, this is pretty much my attitude. I've always included a carbon dioxide emissions table in my book in all 14 editions, but I've never really thought about the implications of it. So putting this talk together has been quite an eye-opener for me as well. And as our techniques for addressing carbon emissions from energy and use have slowly been improving, the relative importance of embodied carbon emissions has increased. Soared might be a better word. We've only just begun to turn our attention to it in a meaningful way. Embodied carbon targets now form a crucial part of the RIB 2030 challenge, which is a green manifesto aimed at architects, many of whom have signed up to its goals. And the very fact that we're talking about it here tonight on an Open Eco Homes event shows it's growing in importance. But before we address the issue of it, first you have to understand it and to measure it. And we'll start with a pie chart. I hope you can see that. It's not the best reproduction I've ever seen on a PowerPoint, but I think you get the picture of it. Many of you are familiar with this sort of pie chart. The whole circle represents our overall carbon dioxide emission, and this one splits it into 5 areas. We're looking at food at the top left-hand corner, transport, the blue section, the 2 on the top right are home heating and other energy use, really energy and use from buildings. And the green slab at the bottom, stuff you buy, which is, they put as 26%. That is what we're really talking about, embodied carbon, stuff that the carbon dioxide has been released before you ever get your hands on it. An awful lot of this stuff turns out to be building materials, cement, steel, bricks, roofing, flooring, pavings, plasterboard, windows, kitchens and bathrooms, plumbing and heating, and even solar panels and heat pumps. In fact, everything shipped to your site when you undertake building work involves upfront carbon emissions. They come from mining, quarrying, harvesting the raw materials, from manufacturing those materials into usable products and then transporting them to your site. Some studies go on to include what happens to the products during their lifetime in the building and also what happens to them critically on disposal. But there's another aspect to this pie chart I wanted your attention to, and that's the little metrics I've added around the edge in tons each. That's tons of carbon dioxide emitted per person per annum. The pie chart works on both a sort of national level and a personal level. And a ton of carbon dioxide, as you can see the bottom left-hand side of the slide, we've got an average per person of around about 8 tons. You'll see the up front figure of about 6 tons, but when you add in all the imported carbon, it's nearer 8. It's much less than some countries such as Australia and New Zealand, where it's at sort of 15, 16 tons per person. But it's much more than most of the developed world, which is down at sort of 1 or 4 tons. That's a much lower amount. So I want you to get your head around this unit of measurement, a ton of carbon dioxide. What does it look like? Well, I actually found this slide this morning, a brilliant illustration of what a ton of carbon dioxide looks like at atmospheric pressure if it was occupying a space. It's about 560 cubic meters, which more or less equates to the space, the volume of a detached 4-bedroom house. What can you do with a ton of carbon dioxide? Well, you get it from burning about 5,000 kilowatt hours of gas or electricity. They're pretty similar in carbon intensity at the moment, or burning 400 litres of petrol, which would drive you 4,000, if you could find it, drive you 4,000 miles in a petrol car. A typical UK home burns between 2 and 5 tons of carbon dioxide per annum. The more efficient the home is, the less it burns. A family flying to Spain and back for a holiday would use about 2 tons. A typical UK home build releases as much as 30 to 50 tons of carbon dioxide. And amazingly, even things like solar panels have quite a high embodied carbon on them. A 16 PV panel array would use as many as 5 tons of carbon dioxide. And it would actually take 5 to 6 years to produce that much energy once it's plugged in. Now, where do you find out more about these things? You go to, there are several databases out there now where you can dig deep into the world of embodied carbon and work out what the footprint of each product you're using is. When I started writing about building in the 90s, none of these existed. And all I had to go on was a group of photocopied sheets available from the Centre for Alternative Technology. The ICE energy database, which is the inventory of carbon and energy, because that's the ICE stands for, came out of work done by the University of Bath around 20 years ago. And it drilled down into the subject in much more technical level than I'd seen before. It's basically just a giant spreadsheet, but it's populated with the carbon factors of any building material you could ever think of. There are many other resources which are available now, and I've listed some of them on this slide here. They'll be available for downloading afterwards. But it's to the ICE database that I return when a query comes up. The basic rules are: first you work out the quantity of the product, the material you're using, then calculate its weight, and then look up the carbon emissions per kilogram weight and multiply the weight by the carbon factor. It's very similar to the work a quantity surveyor does, but you're getting an answer in tons of carbon dioxide rather than money to be spent. So how do construction products stack up here? Just a cursory glance at the figures reveals there are some very basic rules of thumb here, and these are summarized on this slide. You can essentially divide construction products into a few simple categories. Generally speaking, the manufactured products use large amounts of fossil fuel energy to produce, often in kilns or in factories. And as a result, they tend to have very high levels of embodied carbon. Cement and steel are particular bogeys here, because their manufacture involves not just very high temperatures, but also splitting away the carbon dioxide from the basic materials in order to process them. In contrast, natural materials are generally quarried and involve much less processing, and what processing there is less energy intensive. So as a result, as a rule, transportation to site is far less significant, really a second order effect. It's the amount of processing that makes the big difference here. Timber and biomass products are, of course, really interesting. They're natural products, but unlike the mineral-based ones, they absorb carbon as they grow. Exactly how embodied carbon calculators deal with this feature isn't always consistent, because it's actually quite complicated. All trees naturally capture carbon as they grow, but once you cut a tree down, it stops that process dead in its track. Only if a new tree replaces the one just cut down does the carbon capturing cycle continue. In a word, the timber harvesting has to be sustainable, and that relies on a series of product categorizations in place that we never quite know whether they're as sound as we'd hope them to be. Whatever question marks there may be about awarding timber a negative score, because that's effectively what it is when you're sequestering, it's surely better to build with timber rather than burn it as a fuel. Even putting aside any negative scores for sequestered carbon, timber still scores well as a low carbon building product because it's unprocessed, lightweight, and it's capable of spanning small gaps in walls and floors without any additional engineering. We'll move on to a slide taken from a table in my book, in the 14th edition of my book. This is the one I've always embedded in an embedded table, if you like, in my book. It shows how much carbon dioxide is emitted in the production of a 4-bedroom brick and block house. And it does this process of having the quantities down the left-hand column, the weight, and the embodied carbon is down the right-hand column. It comes down to 52 tons in total. This is quite a big, well, it's a 4-bedroom detached house. Interestingly, you can see my cursor working its way around. Have a look at the timber. I've actually given it 3 scores. The timber actually used in sort of joists and rafters has quite a low score of 1.8, chipwood and plywood font 1.0. But we've taken off 2.6 for the sequestered carbon dioxide in italics. That's generally how it's treated. The sequestered carbon dioxide is a negative figure. Note also we've got a pretty high score here for plastic foam insulation. This house only has plastic foam insulation. Also quite a high score for double glazing at 4.2 tons. But the bulk of the score is up here in the top 6 rows. Concrete, bricks, very high, 12,000 bricks, aerated blocks, and cement. In fact, that's well over half the total score. It's up here in the masonry products. That's where the bulk of the processed manufactured goods are. It just so happens that this very point about timber looking good and manufacture and masonry products not looking so great has been explored extensively in the latest issue of the Passive House Plus magazine. It looks at 6 different methods of building the same structure, in this case a 76 square metre end terrace house. It's the first time I've seen such a comparison made in print, and the results are just as anticipated. The traditional brick and block version produces 27 tonnes of carbon dioxide, which is the highest score in the study, whilst the much lighter timber frame version with modified foundations releases half as much CO2, and that's without counting the sequestered carbon dioxide held within the timber, which reduces the total embodied carbon down to a quarter of the brick and block total. The conclusion is pretty much cut and dried. We should be switching away from masonry concrete materials towards timber frame. And as if to emphasize that point, there's been a lovely article very recently by Joe Giddings in the Architects Journal, making comparison with vegetarianism and building. Plant-based options proliferate in supermarkets, he writes. The vegan sausage roll has been a sensation for Greggs, and increasingly it's happened sartorially too. The science is broadly similar for architectural decisions. Plant-based products and materials usually have lower associated carbon emissions and sequester carbon too, meaning they can have a positive impact on our climate. He's proposing it as a rule of thumb that you don't really have to do incredibly complicated carbon calculations, although people wouldn't actually keep doing that, but you just know that this group of products, the timber-based ones and other plant-based products, are very low in embodied carbon, and we should be moving towards building with them wherever possible. Now, you might emphasize the point that Joe Giddings himself is a timber frame advocate. You say, well, he might just be talking his book, but on the other hand, I think he's got carbon arithmetic on his side here. So what should we do as potential builders and of whether we're building new or extensions or renovating? How can we take these lessons on board and try and adjust our plans? Well, one thing I suppose to do is, if you're planning on making your house bigger, is to move away from necessarily a brick and block extension and look at loft conversions, which are heavily timber-based, or buildings like timber studios, the one I'm talking from at the moment, down the end of our garden. Prefer natural finishes over manufactured ones. Here you might be looking, for instance, at flooring, where you've got a choice between stone floors or porcelain floors or timber floor, where if it's the less processed it's been, the less it's been cooked or baked in a kiln, the lower the embodied carbon will be. I haven't really gone into recycled materials here, but obviously recycled materials have only really the transportation element in the equation, and they win out really well. The problem with recycled materials generally is that they're much more expensive than the new products. We had exactly this problem with our house, where we had 12,000 bricks to acquire to do the house, and we did look seriously at buying Cambridge whites, but they were over £2 a brick. We plumped for a developer brick at about a third of that price. That's the sort of calculus that people will be going through all the time. Look out for low carbon alternatives. I've got a slide coming up, which I'm not going to include in the talk here, about low carbon cement, which there are new products coming on the market which do offer options for people wanting to get away from high embodied carbon products. And CCAP professionals familiar with these issues. Well, that's again, easy said and done. There aren't that many. Very often you'll work with a structural engineer on a job, and they always specify as much steel and concrete as they feel safe. You know, no one ever gets fired for putting too much concrete in a foundation. In fact, they're very often very overused, far more than we actually need to use. And finally, I had a quick look at the policy background here, because this is also fascinating. Why are we using so many high embodied carbon products? Well, planning has absolutely nothing to say. It's silent on the issue of how we build. Our building regulations have been covering energy and use since 1970s, with Part L of the regulations getting continually more stringent and more taxing. They have nothing to say on embodied carbon at all. They're blind to this. We have this extraordinary situation with VAT, which I'm sure many of you will be aware of, whereas new house building in this country is zero rated for VAT. So if you're building a new house, you can reclaim all the VAT on the inputs. If on the other hand you're renovating or extending an existing house, you have to pay VAT at 20%. Completely the wrong way around. It should be, you know, we know this is upside down, crazy thinking, and it's been known about for 20, 30 years. Nothing's ever happened about it. The one piece of the jigsaw that is in place that could address this situation is the emission trading schemes, which sets out to put a price on carbon emissions of our heavy industry using the cap and trade mechanism. In its 15-year history, it's been beset by problems and has yet to generate any meaningful carbon reductions. But in theory, if the carbon tax has been raised significantly, it could begin to bite and make low carbon alternatives much more attractive. And I'm sorry to say here that Brexit really hasn't helped matters, because the UK has now left this European-wide scheme and started a parallel mechanism, which to my mind weakens the whole purpose of the continent-wide policy. To date, we haven't broken ranks and gone for weaker targets, but the option is there to undermine the European cap and trade, which is weak enough as it is. In the meantime, we'd like to see some government action here towards rationalising our embodied carbon usage in construction, along the lines of what France is doing. There's some years ahead of us. They've actually introduced a set of targets, including life cycle analysis, embodied carbon use in their building thresholds. This is what we need to have in our policy. The nearest thing we've had to that was the Code for Sustainable Homes, which was axed in 2016. Since then, silence. We've essentially been going backwards the intervening 5 years. Let's hope with COP26 kicking off in just a few weeks, we will start to get meaningful guidance and legislation. That's it, thanks. Let's stop sharing. And
Brilliant, thank you, Mark. Well, that's given us good food for thought. And
any queries?
yes, so Samin, have you got questions in chat yet to call up?
So there's nothing in chat yet, but please, yeah, do ask away.
There's lots of very knowledgeable people on this talk. I'd be interested to hear other people's comments.
Yeah, so there's a question from Nicola. Nicola, I'll unmute you.
Hi, sorry, yes. This is an issue that I've wondered about for a while. Not that I'm very expert on the subject, but how do you do low carbon foundations?
Well, if you like, can I switch back to another slide? Because I've got a supplementary slide. I thought talk 20 minutes was quite enough. If you let me go to the screen share. Are we back in?
Yep.
Oh yes, I want to show you these anyway. These are the next ones.
We'll come to those at the end, maybe those closing slides.
I've gone. Oh, there it was still going. First of all, the slide on why cement is so bad. There's two processes in making cement. We rotate it. Basically, it's formed from ground limestone or chalk and clay. It comes into the plant, and the limestone is calcium carbonate. And in order to, they don't want the carbon of it, so you have to take out the CO2 right at the very start of the process. And 60% of the emissions are actually done before you even start baking the cement. Then it's rotated in a kiln at 1400 degrees C. In theory, this bit, the 1400 degrees C, it's possible to maybe get that done with hydrogen or possibly with electricity. There's a route to decarbonize that, but there's no route really to stop this calcination process at the beginning, where we're separating carbon dioxide from the calcium carbonate in order to get the products that's actually wanted, the lime. The company out in Bourne Airfield, we have a local group called DB Group, which has developed a product called SEM Free. And this is a photograph I took 6 weeks ago. I went out to visit them in preparation for this talk. They've got a work done at the Cambridge University Engineering Labs about 14 years ago. No, sorry, in 2014, 7 years ago. Produced a cementitious-like alkali substance which it isn't made from cement, doesn't involve this calcination process, and they produce this substance that they're using to make bricks, all sorts of things. They've made a staircase out of it. Basically, it is a replacement for cement, and critically, it's actually now available from a ready-mix company in Haverhill, in Hanson Haverhill. Actually, you can ask for the SEM-free product. It's about 30 to 40% more than regular ready-mix, but it's there, it's a start, and it's for a long time this stuff has been available, and this is not the only company working on low carbon cement by any means, but it's very difficult for them. They've been ploughing away at it, getting testing and certification, and there's a lot of suspicion about it from various users. How do we know how long it's going to last? All this sort of thing. Is it as strong as concrete? It comes out as a white colour. It takes a lot longer to go off. It behaves more like lime, in fact, than concrete. But it's there and it's available for people to use on their own, home units. It could be used on domestic products. This. There are other people. There's a guy called Roger Fairs, who's a member of the local AECB group, who runs a structural engineer called Kirkwood Structures in Bassingbourn. And I had a long chat with him about what are the alternatives to doing concrete foundations. And he suggested that one is to use steel screw piles, where you can say you're jumping from the frying pan into the fire by going from concrete to steel, but in terms of volume, they're a lot less. Very widely used in Australia, not so much here. You still often have a concrete ring beam around the top. He also suggested there are people working with Accoya, which is this improved timber, which is sort of like baked in vinegar, and that timber itself might be used for foundation, or stones that have been compacted. There are various things about it, but we're at the fringes of construction techniques here, and they're not really anyone around at the moment who could just say, I want a compacted stone foundation. You would probably find no structural engineers at all, and certainly no builders be prepared to do it. But one very simple point is just to have a leaner specification. People specify far more concrete than is actually needed. For instance, a concrete trench is routinely cut at 600 millimeters wide, which is the width of a bucket, but there is also a 450 millimeter wide bucket. That means that you've cut the amount used by a third, but you've got to be that much more accurate. You can't, because the walls are going to be 350 millimeters wide. So there are little things like, just being slightly less risk averse with the specification helps. So there's various things out there, but there's not an easy route for people just to go along and say, I want to use less concrete,
There's a question from Anne Miller. And do you want to ask a question? So actually there's and 3 or 4 questions after that. So
okay.
Hi there. My question is, why is it, do you think, that planners require brick skinned buildings? I mean, it seems absolutely ridiculous to take a perfectly good timber frame building and then put a brick skin on it. Or is it the planners that are requiring that? And of course, I mean, I think your house has got a brick skin. Is that right, Mark? I can't quite remember.
We have mostly brick skin. It was actually, we're building on a boundary. We had to have something that was fireproof. We couldn't build timber down the side walls because we've got the two long walls built on the boundary. So it's got to be something inflammable. And I guess the planners want something local. So in Cambridge, it's all let's use more, cream-faced Cambridge white type buff bricks. And the truth is, once you move to inflammables, you could use brick skins, brick slips, but they're very often made by cutting a brick in half. You don't actually have much carbon saving out of doing that. Or you're baking. I mean, you could use core 10. There's various things you could use which wouldn't. You're not going to use a plant-based material on it. But bricks is easy. That's it's really it's inertia as much as anything, I think.
It seems to be increasingly. I mean, when we're getting houses that are solid wall insulated, you end up with a rendered surface.
Yes.
And the sort of traditional sort of Suffolk style of building, which is really pretty close, you know, is a a rendered plastered, sometimes even pargeted surface, or you know, black timber boards. So it feels to me like there'd probably be massive carbon savings if we could all somehow beat up the planners, or is it the architectural heritage people, to be a bit more up to date.
Well, another issue with bricks is the mortar used to lay them. Now, if we go back, the reason you can buy reclaimed Cambridge whites used in Victorian times is they were laid in a lime mortar, quite a weak lime mortar, which you can clean off the brick when you actually take the wall down. You can actually tip it. I remember doing it many times in the 80s. We'd be cleaning up bricks. Today we use a cement mortar, and that's actually stronger than the brick. And so that once you take a cement brick wall down, it's good for nothing more than hardcore. So that's another development that's not really happening. Is having soft enough mortars so if you did use bricks, at least you could reuse them at the end of their life. But we're nowhere on that at the moment. Absolutely nowhere.
And I think I've heard that having a lime mortar actually helps effectively suck the moisture out of the brick, so that your wall ends up drier and being a better, more insulating. I don't know if you think that's correct.
The problem with lime is it's very much slower to lay. You lay lime in winter, you can wait a week before, you know, it just doesn't go off. And that's actually one of the problems with Semfree here, is that it's much slower to set, and people worry about, you know, they're on a budget, they're on a time schedule, they can't hang around and sit and wait for the paint to dry, or in this case the lime or the concrete. Again, it's, you know, the very intrinsic to our construction basis. Everything's going to be done in a hurry in the way we know how, and this just hasn't been considered. I can't hear what's going on now. I've lost it.
Samin, have you got more questions to call on? Oh, maybe I think maybe his. Can we hear you, Samin?
Yeah, can you hear me?
Oh yes, yeah.
Yeah.
Good.
So there are four or five questions to come. I'm asking Jason next. Jason Palmer.
Sure. Hi, Mark. Another question about cement or concrete performance. You talked about the longer drying time, but are there any other compromises in terms of performance when you're specifying Semfree or other low carbon cements?
To be honest, I don't know. I've really not covered this issue till we went out to see DB Group. And there are very few people out there who would know. Like, you know, I talked to a couple of structural engineers and they'd never used it. And so you're in the hands of DB Group and what they say. I think they're a fairly reputable business, but really we have to make our own investigations. But we're in uncharted territory here.
Fair enough. Thank you.
Okay, Tom, you had a question?
Okay, well, I think my question was largely answered about the planners, but I was just going to sort of cite my frustration, really, that there's a great passive house development by King's College on Barton Road called Croft Gardens. Lots of student housing going up. The structure is cross-laminated timber, which they're claiming a lot of sequestration for, but the Cambridge City planners insisted that they have brick facings to these buildings, which certainly the guy managing the site was unhappy with. Well,
interesting to say that. There was actually a report just again last month in London. Sadiq Khan, the mayor, has actually put a proposal to ban all flammable claddings to all buildings in London. This is, you know, après Grenville, you know, it's not just tower blocks. It's not even four-story houses. It's talking all housing, including, you know, detached suburban sort of housing. We may be overstepping the mark. I mean, we've got, you know, North America is a timber frame country. Scandinavia builds houses in timber frame. They're not all suffering from huge problems with you know, with fire, and I think we're possibly throwing the baby out with the bathwater here. because I think there are lots of ways of cladding where there is flammability is not an issue without going to brick, but it's difficult, isn't it? Yeah.
Okay, and then Chris Poynton had a question.
Thanks very much. My question harks back to the a bit of the conversation about lime cement and the bricks being reusable. What else is going on around making building construction techniques recyclable or recycling friendly at sort of end of life?
Well, this is one of the things that grows out of life cycle analysis. When we get to, I've got another. Oh yes, this is. This is a proper life cycle analysis done professionally, and there's and this is a skill that's grown up over the last 20 years with these databases. There are far more things to take into account than the simple embodied carbon in manufacture. I can barely get my head around this. I certainly don't know sort of talk about it, but there is points. Basically, end up giving points, and there are points for having recyclable material. And there is some smattering of people getting involved with it, but essentially, we give buildings a 60-year lifespan, which in itself is very questionable. But when they do these life cycle analysis, they tend to think it'll last 60 years and that'll be it. One thing we can do, obviously, is build buildings that will last longer than 60 years. If you double the length of the lifespan, then you halve the overall embodied carbon emissions, and you've made recycling less of a problem. But I generally speaking, builders today pay zero interest in what happens to the products at the end of their life, and everybody is, in fact, the whole history of building in the 20th century has been about using more and more manufactured materials. If you go back to under Edwardian Victorian times, it was still a very craft-based business. Using homemade lime to make the bricks, and the bricks themselves would have come from the Cam River terraces, and the joinery is all made up so, and it was all very repairable and quite, not so rigid. There was movement allowed in buildings, and you could get around and repair it. Everything's become much more simplified. We're using manufactured materials, plaster boards where there was once lath and plaster, and it's basically that makes it that much harder to recycle it. A sheet of plasterboard reaches the end of its life, you're not going to recycle it. It's just not possible. And really, the story is of going the other way. We're making less recycling. I don't think it's begun to be addressed how we would actually start building buildings that could be recycled. Glazing is a good example. We're moving towards double and triple glazing, aren't we? I've actually got a slide on a very interesting case of is triple glazing a good thing to do? I mean, obviously you get a better energy performance out of triple glazing, but it comes with a much higher, 50% higher embodied carbon, and actually the payoff is something like 20 years, because the difference in a really good double glazing and the triple glazing it is actually quite small, and this chart here is comparing the embodied carbon of 3 different materials, and actually the materials you're using is actually probably more important than whether you're doing double or triple glazing, but it's quite marginal. And triple glazing in our climate, which is fairly mild, in terms of overall energy use over, I mean, how long does a double glazed, triple glazed window last? I mean, we don't really know, but we're probably doing well if it's 30 years. And the old days we were using single glazing, and it broke. There are many Georgian windows in London and other cities which are still being used from 200-300 years ago. So having high-tech windows, which we're doing, it comes with a very high embodied carbon cost. Interestingly enough, I mentioned at the beginning about PV panels having quite a high embodied carbon. They're not that different to triple glazing, actually, and in terms of per meter square score. So I don't really think, to come back to your question, I think the answer is quite close to zero. Anything, it's all going the other way. It's going to more and more upmarket high-tech products that have no future once they're finished with. That's probably true of life in general, isn't it, rather than just building, I think.
Am I allowed a little follow-on question?
Yeah, do.
Just wondering who one leans on to move the needle. Is this a problem that architects aren't used to specing buildings that have this as a consideration, or that the construction engineers, the civil engineers don't have the toolkit, or that the builders haven't got the skills, or the planners aren't making the right sort of putting the pressure on right? Where ought we should be banging on the door? And
Yeah, I mean, yes to all those, and I open up, and anyone else got some comments on it, because I mean, in digging into this subject, which I've done with this talk, I think, you know, we're almost nowhere with any of this stuff really, and we're just at the beginning of the journey. You know, it's like we was looking at energy and use for the last 50 years ago. Embodied carbon's been completely ignored, and yet it's critical when you look at the, here we're talking about building how many new homes in the Oxford Cambridge Arc? 1 million, is it? Something like that. We're very keenly aware of the water abstraction issues. We're not looking at the fact that each of these houses is going to be emitting 50 tons of CO2 in its construction phase. It's a phenomenal amount of additional carbon use, with in the overall national picture. And is there, you think, well, should we be switching to timber frame? At least we could probably halve the amount of COU using the sort of low carbon building materials. There's not even discussion of it, is there? The whole housing debate's couched in units. We want so many units, and we've got the plan out in front of us at the moment for, I don't know, South Cams wants, how many is it? 60,000? I forget the figure, but it's phenomenal. I can see Anne shaking her head.
It's in the local plan, it's 44,000 new homes by 2040, but the catch is that 37,000 odd are already in the planning process. So those are already baked in. The minimum number of homes that the government would allow us to have would be 37,700. You can tell who's been writing an article about this morning.
Yes, this is great.
So basically, what they should have done, I think, in the draft local plan would have been gone for the absolute minimum number of new homes that the government would allow us to have done. Because if they went for less than that minimum number, then apparently what happens, the catch is that the plan is deemed invalid, and the developers are all given a complete free-for-all. So then we'd just be all completely raped. They have gone, they've gone for a bit more. At one point, they were talking about the maximum option. Well, there was the potential maximum option, which I think they were never going to really do, was 60,000 odd. But so what at the moment they're saying is 44,000, which is, what's that, 7,000 odd more than the minimum they need to do.
And what do they have to say on how these homes should be built?
Well, actually, I've just put a link in the chat to the local plan, the climate change bits of the local plan. And the climate change bits are actually really good. I suspect Emma Davies at the City Council, the Greater Cambridge Planning Service, has had a lot to do with it. But I've just written an article for the Cambridge Indie for the next week about this. But I suggest everybody goes and has a look at the link, and then you can see some, when you go to that page that's the link I've just put in the chat, you'll see some sub-pages, so you can look at the plan, their proposals for policy measures for zero carbon buildings, which, for example, say the energy demand has to be 15, whatever it is, kilowatt hours.
Passive house level. Yeah.
Really passive house, yeah. I think they're saying 15 to 20.
Yeah.
Whereas I think passive house is 15. I think it's a bit bizarre that they're not allowing houses of passive house or better. But actually, I think that's really promising. And there is a rather vague statement about embodied carbon, which I suspect won't mean much in practice, but so I'd be quite interested in how that could be strengthened. But I think it's quite important that all of those that care about this sort of stuff and know about it should go and have a look at these bits of the local plan and actually come out in support and stop the developers whittling it away and weakening it, because I'm sure the volume house builders will absolutely hate it. But I thought it was in general was pretty good. At least the low carbon bits. There's loads I haven't looked at.
I mean, passive houses are interesting because it's held up as a sort of gold standard of low energy building. It too is silent on how you build them. It's nothing to say on the embodied carbon aspect of it at all. And I was sort of brought up with those. So I've been working on energy efficient housing since 1980, in fact, when I first got involved with construction. And I was taught, you know, it's all about energy use. It's all about energy use. You could ignore the embodied carbon, but really it's not true. It's actually a huge chunk of release. And also the fact is when you build it, it's being released now while it's being built. You know, it's not as though, and I've seen South Cams are actually saying we're dividing, let's say it's a 60-year lifestyle. They could take the embodied carbon and divide it by 60 and spread it out over the 60s. Well, the arithmetic doesn't work like that, does it? It's the cumulative carbon dioxide in the atmosphere that's the critical issue, not whether it's you can write it off over 60 years. You know, if it's 50 tons written over 60 years, it's still nearly a ton a year, isn't it? It's still a hell of a lot. And you know, I suspect this is one. It's almost like an elephant in the room in energy politics because it's not really being addressed.
Can I chip in, Simon? Just on
There's
this point?
one or two more questions. Margaret Reynolds about insurance. Margaret?
Looks like she's frozen.
Can't get you, Margaret. No.
Yeah, we can't hear you properly.
Can you hear me?
Yeah. Yes, ask your question.
Maybe type it. You can't get through on the audio.
And then John, so let's come back to Margaret. John Darley had a question.
Yeah, relating to Nicola's question about foundations, if approximately 70% of embedded CO2, embodied CO2, so is in the structure, the foundation is generally a large part of that. What are the low embodied options? I mean, is limecrete an option? I'm trying to work out whether limecrete is a sensible option, both in terms of CO2, availability of the resource, and also structurally. I don't know if you've had any experience with that.
Was that addressed to Nicola or?
No, sorry, just because Nicola asked a question about foundation.
All right, lime is basically not that different to cement. It's what the Romans used to make cement out of. It's exactly the same problem. You've got to split the CO2, the calcination process goes on. Interesting enough, what happens is very slowly the CO2 recombines with the lime and indeed with cement over decades. So there is a sort of slight sort of, almost like a sort of a sequestration going on. And I believe lime does that a bit faster than cement. But the problem is it's not as strong, and as we said, you know, there's lots of problems with using lime, which most builders won't really buy into. But the process of making lime is you know, cement is essentially a more industrialized, higher heated version of lime. It's not chemically that different in the process of making it, although it used to be made a sort of craft thing in a lime pit in the back of a garden. It also involved very high heat.
Because somebody had mentioned that hot lime was quite a low embodied CO2 way of doing things.
I don't know about that. I mean, you jump into the ICE database, you can look it all up. You know, it's better, but it's not way better. It's, you know, like 10-15% better than cement. It's not a, you know, it's still the same process of breaking lime away from limestone.
There's no more questions for Mark. The rest is kind of chat amongst people themselves.
can I chip in? Really in answer to Chris Poynton's, well, and other people's questions about what can we do politically. Earlier on in the chat, I put a link to a campaign by ACAN, which stands for Architects Climate Action Network, and they have an award-winning campaign about regulating embodied carbon. So do have a look at that link. They have some really good resources explaining more about why it's important to regulate embodied carbon, and they have a petition and so on, you know. So that's the only sort of, it's a national campaign on this topic.
There is, funny on that subject, there's a talk tomorrow. Now, I haven't got the link, the lunchtime talk tomorrow on natural building materials. Maybe I can actually find the link rather than sort of sitting waffling about it, and looking at this very issue. And I think someone from ACAN is talking at it. I'll see if I put the link in the chat. Please talk amongst yourselves while I'm looking.
Or if you want to send me the link afterwards, Mark, I can put it in a follow-up email.
Let's do that. Yeah. I mean, I don't know what I think it's a big subject, isn't it? But there's no really easy solution to this. I can see it's going to take years, you know, to work it up into something meaningful. But and it may be quite difficult. I mean, the obvious thing is building timber frame. For a start, you have a lot lighter. The house is lighter. You need less in the way of foundations. But that's a battle that's been going on really for the last since World War II. You know, the UK is wedded to masonry construction. Not Scotland, funny enough. Scotland is timber frame culture that they've embraced in the 1960s, and 80% of the housing in Scotland is built in timber frame, albeit with block walls with render on. And many other countries, as I mentioned, North America and Scandinavia, build almost all their domestic properties in timber frame. It would be quite hard for us to switch over to that, just logistically. You know, there wouldn't be enough timber. We import all our timber. I mean, basically, that's the main reason that countries build with the local materials, and we cut up most of our timber down, you know, in years gone by. It's giving us one of the lowest timber forested countries in Europe, I think, aren't we? So to switch to that is all very well saying in theory. In practice, it would be logistically quite difficult to start to move away from heavy masonry materials over into timber frame. And similarly, like using recycled materials, it's all very well that we can, as individuals, possibly incorporate recycled materials into our work, but it's not going to happen on a sort of policy scale where we're building 30, 40,000 houses a year. It's really only scratching the surface.
So there was only one question left from Margaret Reynolds. I can't.
Hello. I'm on now, I think.
Okay, great. Okay, go ahead, please.
Well, it was a question about insurance. I remember discussing with Cambridge Association of Architects about using hempcrete, and they said at Mole Architects that they'd done a lot of research on this, but that no one would insure a building made of hempcrete or using hempcrete. And I think it's a more fundamental question. Insurers are conservative, builders are conservative, even structural engineers tend to be conservative, but we need an innovation. And it seems to me the only way we're going to get somewhere is if there's some kind of public body that can look into these things and help the industry to get recognition that these things are safe, whether it's a BBA certificate or whatever. And people are just not going to be rushing in to making buildings with unknown materials, buildings, you know, safe as houses. People just are very anxious about that. And so we need government to sponsor research and to sponsor some of these materials.
I agree with you completely, and I've been covering this in the self-build sector for well, it's decades now, where people want to take on some slightly exotic build system, straw bale, you know, you name it. People are out there experimenting with them. There's the mortgage issue, you know. There's the wonderful Ecology Building Society up in Yorkshire, which covers all these sort of non-standard building methods, but it's tiny. It does like 100 mortgages a year, you know. There is a company called Insure Green, which is based somewhere down in Kent, I think, and they say they will take on, you know, non-standard projects, provided they've got they're confident with the surveyor or the architect backing it. But it, you know, we're just scratching around the surface. You know, the BBA certificates, in theory, it's great. It's got a pretty bad press over Grenville. You know, they were busy certifying all these strange cladding systems that were obviously not fit for purpose. So it's a very difficult area, and moving wholesale to sort of you know, products like hempcrete is probably a step too far for a lot of builders. You know, they could comprehend timber frame with maybe mineral or rock wall insulation, but not to go right the way down to having hempcrete. But I can but say you're right. It's difficult. It's one step at a time, and it's not going to be a revolution overnight. Tom.
So I think to finish on time, we need to get on, and I'll launch the closing slides in a minute. But thanks a lot, Mark, for really stimulating a lot of thought here. Plainly, we haven't got all the answers, but we know there's a big problem here, don't we? And there are some things that if we're doing our own retrofit or build, there's some good choices to make. So I'm just going to share a couple of closing slides. And so there's one up, I hope, about next steps. And so it would really help us, please give us your feedback on this talk this evening, on this link. I think Samin is pasting it into chat. So there's a jot form, a short feedback form. It'll take you 5 minutes at the most, but it's really helpful to enable us to make open eco homes even better. As you expect, I'm going to ask for a donation, or thank you if you've already made one. But this is run by the charity Cambridge Carbon Footprint, and we really need donations to be carrying on doing this and extending this work. And so perhaps you can also share on social media about what you've seen and other things that are coming up. And final slide, if I can get there. Yes. Okay. And so here is just a link of some further resources. I'm not going to go through this in detail now, but you will get a PDF of all these slides where the links should be clickable. So there are things you can follow up there. Maybe if you're interested in retrofit, we're having, well, there's already some online things there, and there's a talk later about planning your retrofit that may be useful. But anyway, lots of other resources there. So I think now we're going to, it's 8:30 or so now, I think. And so I think we're going to formally close this session. But in fact, we're going to have a bit of extra time. If you're interested to ask more or make suggestions, raise your own ideas, there'll be a little opportunity to carry on doing that afterwards. But now I'm going to say thanks so much for coming this evening, and I hope this has been useful to you. And so just stay on, or if you need to go now, feel free. We'll start again in a minute or two. So I see some participants leaving. We'll go on for a bit more, I think. Do you want? Is there some other direction you want to take us in, Mark? Other things that need saying?
No, I'm exhausted of the scale of it. It's a big topic, and it's I feel I've only scratched the surface, and I have no particular axes, any more axes to grind.
I was interested to raise the question of steel. So, what is the scope? I mean, I look online and I see a lot of previous pre-used, pre-loved RSJs. You know, you could do building work using reused steel, or I don't know whether you can buy steel work made out of recycled steel.
Well, I started my building career buying steel RSJs from Solo Park when it was still a very small business. These days, it tends to be the structural engineer tends to have jumped in and sort of say, you know, they specify specific steel you've got to have, and you know, this channel, this weight of steel, and that's very difficult to find that in a second-hand market. So I think it's an example of a product that used to be rough and ready and has become much more professionalized, and in doing so, it's moved away from second-hand RSJs into the world of buying steel off steel stockholders. So I think again, there's another product we're going backwards on. There's talk in the press, isn't there, a Swedish zero carbon steel manufacturing going on, isn't there? And but again, it's people chipping away at the fringes. I guess it'll be decades before that becomes mainstream. But there is potentially a route to zero carbon steel. So some of these products, you can see a way in 30 years' time we could be making them for zero carbon energy. I'm not sure really where we are with steel. I don't know enough about it, but recycled steel, I think we're using less and less of it.
So if you've got a question or a comment, we're a smaller group now, you could shout it out, I think.
I've allowed people to unmute themselves.
Yeah.
So Githa has a question. Githa, you can ask your question, okay? I think you can just ask. You can unmute yourself now.
Oh, hi. Yeah, sorry, I don't know if it's slightly off topic, but yeah, I've just purchased a listed building. It's actually in Norfolk, so it's not in Cambridge, but I'm struggling in regards to heating systems because due to being a listed building, I may not be able to house an air source heat pump on the exterior. And I was looking for really high efficiency electric heating systems, but I'm a bit stuck really. I also can't have solar panels on the roof because it's a listed building. So does anyone have any ideas, please?
It makes me wonder with, I've seen some air source heat pumps where the outside exterior unit is very well hidden under kind of beautiful louvered wooden boxes or shelters, or is there a way of camouflaging your outdoor unit so that it might be acceptable?
The issue is I've only got about 1 meter around the perimeter of the building, so there's barely any outdoor space. And I don't think there's enough space even to box one in on the exterior. Not that I think they'll let me because it's conservation area and it's listed. So yes, I'm struggling there.
That's hard.
Also, the building's not going to be very well insulated, so the prospect of having an air source heat pump in practice may not be very effective because the walls won't be very well insulated. Yeah, it's a bit problematic in terms of energy efficiency, but there we go.
It's a bit off topic for us, isn't it? I mean, you could probably spend half an hour running through this, and I'm not sure we really got time to do it tonight.
Not to worry.
Presumably you've looked at insulating inside from the inside, internal insulation.
I have. I just lose the space on the interior, obviously, but yeah, it could be an option potentially. I may have to.
Get very low thickness.
Mm,
I can't remember the brand name now, but that's what we had.
okay.
Certain parts of the house.
Okay.
Was it aerogel?
Aerogel.
Aerogel.
Yes. But
I'll
it's
look
much
at that.
expensive. It's like 3-5 times more expensive.
Gosh. Okay, I'll take a look, but thank you.
I'm going to have to sign off myself tonight.
Yes, well, maybe we are coming to a natural close.
I'm meant to be going to see Martha Wainwright in the Junction in about 10 minutes.
Oh, wow. We're missing that.
So I don't want to miss the beginning of that, do I? So I think I'm going to have to call a halt to that.
Okay. Well, thanks a lot, Mark. I think we've had a useful session.
Well, it's interesting, isn't it?
Time to play.
Quite a good turnout, and you know, it's one to think about. It's not one. You know, it's a difficult nut to crack. This it's not as easy as just installing a heat pump or a bit of insulation.
Sure, complicated. Thank you.
With that, I'll bid you all farewell and good night.